Welcome to Programming Fluency. This is section 6.1, Pointer Basics. Pointers are often called the hardest part of C, but they rest on one simple idea. In this video, we build that idea step by step, starting from scratch. Let's begin. So far, you have worked with variables that hold values like numbers and characters. Now you will meet the most powerful tool in C, a pointer. A pointer does not hold a number. It holds a memory address. Let's find out what that means and why it matters. This is the plan for this video. First, we start with the big idea. Every variable in your program lives at a memory address, and a pointer is simply a variable that stores one of those addresses. Next, you meet the two operators that make pointers work. The address of operator, written as the ampersand symbol, gives you a variable's address. The dereference operator, written as the star symbol, follows a pointer to reach the value it points to. Then we read and write through a pointer. You will see the mental model, understand why the ampersand and the star are inverses, and learn how to change a variable through its pointer. Finally, we talk about safety. You will meet null, the pointer that points to nowhere, and learn why you must never follow it without checking first. Every variable you have declared, every int, every double, every char, lives somewhere in memory. That somewhere has a number. We call it a memory address. Think of it like a house number on a street. Normally, you do not see this address. You refer to the variable by its name, and the compiler handles the rest. But you can ask for a variable's address directly, and that is where pointers begin. So what is a pointer? A pointer is a variable that stores a memory address. Most variables hold data, like the number 42, or the letter A. A pointer is different. It holds the location of data. It holds the address where some other variable lives. With a pointer, you can reach into another variable's memory and read its value, or even change it. That is what makes pointers so powerful. You get a variable's address with the address of operator. That is the ampersand symbol. Here we declare int x equals 42. Then we print two things. First, the value of x, which is 42. Then the address of x using ampersand x. The %p format specifier prints an address in hexadecimal. Do not worry about the void star cast for now. It is just the syntax print needs for %p. Look at the address. It is a big number. It will be different every time you run the program because the operating system decides where to place your variables. Let's write down the definition. The address of operator is a unary operator that returns the memory address of its operand. If x is an int, then ampersand x is the address where x is stored. And something nice is true. This is the same ampersand you have been writing in scanf. When you write scanf, %d ampersand x, you give scanf the address of x. That is how scanf knows where to store the value the user types. Without the ampersand, scanf would get the value of x, not its location, which would be useless for storing input. To declare a pointer, you put an asterisk between the type and the name. Read these examples. Int star p means p is a pointer to int. Double star dp means dp is a pointer to double. Char star cp means cp is a pointer to char. The star means pointer to. The type before the star says what kind of data the pointer will point to. So an int star points to an int. The type matters because it tells the compiler how many bytes to read when you follow the pointer. Now let's make a pointer point at a variable. The line int star p equals ampersand x creates a pointer named p and stores the address of x inside it. Look at the output. X is 42, ampersand X is some address, and P holds that exact same address. The pointer P does not contain 42. It contains the address of the box that contains 42. See how P and ampersand X print the same value. They are both the address where X lives. Let us build a picture. Think of memory as a row of numbered boxes. This is the pointer P. It is one box. Inside it, P holds an address. The address is 0x1000. Now here is X. It is a separate box in a different place in memory. Inside X is the value 42. The arrow means points to. P points to X because P holds the address of X. That is the whole idea. One box holds an address and it points to another box. Storing an address is only half the story. The real power is dereferencing. That means using the star operator on a pointer to reach the value it points to. Here P points to X when we write star P. C goes to the address stored in P and reads the value there. Since P holds the address of X, star P reads the value of X. So X is 42, and star P is also 42. The star follows the pointer to its destination. Let's write down the definition. The dereference operator is a unary operator that accesses the value at the address stored in a pointer. If P points to X, then star P reads or writes X. Now notice the symmetry between the two operators. The dereference star is the inverse of the address of ampersand. Ampersand X takes a variable and gives you its address. Star P takes an address and gives you back the variable there. So star of ampersand X is just X. The two operators undo each other. Start with the variable X. It holds the value 42. Now apply the ampersand operator. Ampersand X gives you the address of X. The blue arrow goes from the variable to its address. Now apply the star operator. Star takes that address and gives you back the variable. The green arrow goes from the address back to X. The two operators undo each other. Dereferencing works for writing too, not just reading. You can assign to star P to change the value that P points to. Here the assignment star P equals 99 means go to the address stored in P and write 99 there. Since P points to X, this changes X to 99. Look at the output. Before, X is 42. After, X is 99. See how X was never named on the left side of the assignment. It was changed through the pointer. Before the right, this is P. It holds the address of X, which is 0x1000. And here is X. It holds 42. P points to it. Now we run star P equals 99. Look at X. Its value is now 99, shown in red. The right went through the pointer into X. And look at P, it did not change. It still holds the same address. It still points to X. The pointer never moved. Only the value it points to changed. Sometimes a pointer does not point to anything yet. Maybe you have not given it an address, or the thing it pointed to no longer exists. C gives you a special value for this situation. It is called null, spelled in capital letters. Here we set int star P equals null. Then before using P, we check. If P is not null, we dereference it. Otherwise, we print a message. Because P is null, we take the else branch and print P is null, cannot dereference. Checking first keeps us safe. Because P holds null, the check, if P is not equal to null, fails. So we take the safe else branch instead of following the pointer. The program prints P is null, cannot dereference. We never touched the bad address. Checking the pointer first is what kept us safe. This is the most important warning. Never dereference a null pointer. Look at this code. P is null, and then we write star P equals 5. This is undefined behavior. The C standard says nothing about what happens. On a normal computer, address 0 is off limits, so the operating system kills your program with a segmentation fault. That is the famous crash beginners see. The rule is simple. Before you dereference a pointer whose value you are not sure about, check if P is not null first. This one habit prevents a huge number of crashes. Now the payoff. Back in Chapter 4, you learned that C passes arguments by value. The function gets a copy, not the original. So a naive swap function cannot change the caller's variables. Pointers fix this. This swap function takes two int star parameters. Inside, star is the value of x, and star b is the value of y. We save star in temp, copy star b into star a, then put temp into star b. In main, we call swap with ampersand x and ampersand y, passing the addresses. The output shows x is now 20 and y is now 10. It worked, because swap used the addresses to reach into main's memory. Let's recap. A pointer is a variable that stores the memory address of another variable. You get an address with ampersand, the address of operator. You follow a pointer with star, the dereference operator. These two are inverses. Star of ampersand x is just x. You declare a pointer with a type, a star, and a name. An int star points to an int. Null means the pointer points to nothing, and you must never dereference it without checking first. And the big idea, passing an address lets a function modify the caller's variable, even though C passes by value. Next, you will learn pointer arithmetic. What happens when you add one to a pointer, and how that connects to walking through an array.